All right, let's go. 1-5, graphing linear inequalities. Let's see here. First definition today, linear inequality, what it is. Resembles a linear equation. All right, so what we did yesterday with the graphing of the lines and stuff like that. But it's got an inequality symbol instead of an equal symbol. Okay, now that's going to change a few different things. All right, and we'll kind of pick on those as we go through the first couple of problems. So there's a graph. That's cute. Here's the equation. All right, this is something we graphed yesterday. All right, y equals negative 3x minus 2. You start on the negative 2 on the y-axis, and you're going to move down 3 and right 1. It graphs like that. Okay, that's how you're going to graph these today also. All right, nothing changes as far as that goes. One little minor tweak on a certain thing, which we'll get to in just a second. Now, what this graph does for you is it divides your xy plane into two halves. Right? You have half 1 over here, and you have half 2 on this side of the line. So it divides it into two halves. Now, what we're going to have to do today, oh, that's called your boundary line too. Sorry, thought I mentioned that. That's called your boundary line. Now, what you're going to have to do today, and this is an example of what it's going to look like at the end, is you're going to have to shade one side or the other. Okay, because these are going to be inequalities. All right, now think back a couple lessons ago. We had x is greater than 3. You guys would go to a number line. You would do what type of circle? Anybody remember? Open circle on 3. And then you would shade this to the right. Okay. Why would you shade that to the right? Because those are where your x's are greater than 3, right? Or to the right of 3. It's the numbers that made that inequality be true, right? That's what you shade. You shade the truth. Same thing is going to hold true down here. Okay, we're going to shade the truth, and that's why this side over here is shaded with this one. Okay, and it's a very easy process to get that done. Okay, but that's kind of the intro to it. All right. Cool, cool. All right, next up. Now, one of the minor tweaks about this is your lines, when you graph them. Like the example I just showed with the x is just strictly greater than 3, we did an open circle from last time. Yes, remember? Here, when it's strictly less than or greater than, you're going to draw that line with a dash. Okay, dash line, dotted line, however you want to say it. But it's got to be kind of dashed. Okay? So that's kind of one of the harder things about it. You got to kind of learn how to draw a straight dash line. If you have your wallets or a calculator, your calculator edges work really good for straight edges. Any old gift cards, student IDs, stuff like that works really good for straight edges. Those are my favorite. They work the best. So those will come in handy this chapter, this lesson too. And then if it's equal to also, it's a good old solid line. Okay? Any questions on the intro stuff? Pretty straightforward, pretty good? Cool. Moving on. So, we begin. Y is less than negative 2/3 x plus 2. So what's my y-intercept on this line? Y-intercept. 2. 2 on the y-axis right there. Okay, what's my slope? Negative 2/3. So from 2, right here, I'm going to go down 2 and right 3. So right there. Okay? Down 2, right 3. I could also go from here up 2 and left 3, which I think is right. Nope, it's one too far. There we go. Right. Okay, what type of line here? Dotted, dashed, or what have you. Boom. Pretty slick, huh? I'm so good at that, you missed me do it. Like I went dot, 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 got them all, right, book? Yeah. Okay. Now, obviously, yours is going to take a little more time to do, okay? Try to make yours straight. The only thing I'm going to tell you, though, make sure you get all the way across the graph, whatever graph I give you. okay, for a reason. All right, we'll get to that a little later. It should be somewhat obvious, but we'll get to it a couple of lessons from now. Okay, so we got our line graph correctly. We're going downhill, which is good because we got a negative 2/3 slope. Now, the only thing we have left to do is figure out which half to shade, whether we're going to shade this half of the graph from the line or the top half from the graph of the line. And it's really easy to test, okay? This is called a boundary basically because it makes a fence, right? It makes a fence, divides your graph into two. And you want to shade the truth. So what you do is you pick a point on either side of the fence and see if it's true or not. Now, the nice part about these is one side will always be true. Always. There's not a case where like they're both false or they're both true. One will be true, one will be false every time. So the good part is you find the truth, you shade the truth. You find the false side, you shade the other side because that's automatically going to be true. Okay? So you pick a point. You can pick any point up here as long as it's not on the fence line, boundary line. Okay? So what point you want to pick? -2, got to be a coordinate, so you got to have two numbers. -2, 1. Okay, that would work right there. See that? That would work. What else would work? I'm thinking easier. -1, 1. That would work. I'm thinking even easier. 0, 0. It's about as easy as it comes. All right? Plug in 0, 0. Okay? And you test that into your original inequality up here. Okay? So we're going to test 0, 0. I'm going to highlight it in blue right there. Okay? You don't have to do this step necessarily. But you plug 0 in for y. You plug 0 in for x. And then you simplify. So 0, you can hardly see that probably, huh? So 0 is less than 0 times -2/3. Here's 0. 0 plus 2 is 2. So 0 less than 2. True or false? It's true. Since it's true, you shade the truth. And so from the line that you graphed, you shade the side that includes 0, 0. You don't need to go so crazy with your shade that you like go through your papers. All right, you don't need to go that hard, but please go harder than just this. That's not really shading. That's a stray mark that I really don't know what you're talking about. Okay, so at least go, somewhat decent so I know. Okay, but that's it. That's a problem right there. All right. Any questions on that? Everybody good up there? All right, next one. X plus 4y is greater than 2. What's the problem with this one? What's not good? Not in slope-intercept form yet. So we got to do a little work, okay, and make it in slope-intercept form. Which isn't bad, right? Subtract x from both sides of it to give you 4y is greater than -x plus 2. And then you divide by 4. And make sure when you divide by 4, we divide everything by 4. Okay? So which gives you y is greater than -1 4th x plus 1/2. And that's the line you graph now. Okay? Now, your y-intercept in this case is what? That's your slope. What's your y-intercept? 1/2. 1/2, right? Positive 1/2. So it's going to be right there. Right between 0 and 1, right? Which is kind of weird for you guys, right? You haven't seen a whole lot of y-intercepts that aren't whole numbers. Okay? And to be honest, you probably won't from here out. Okay? The worksheet generator doesn't really like it. The book doesn't really like it. I put this one on here just to show you guys and make sure we understand what slopes are. Okay? How do you move? What's your slope? Book? negative 1/4, which means we're going to move down 1 and right 4. Okay, now when we say that, we just assume we're talking about down 1 unit, right 4 units. Yes? Okay, so from 1/2, we're going to move down 1 from 1/2, whoops, wrong screen, 1/2 to negative 1/2. Okay, so it's not like you go from 1 or from 1/2 down to 0 or from 1/2 all the way down to negative 1. You move 1 unit. It's basically doing 1/2 minus 1. Okay, so you go 1/2 to negative 1/2, and then we're going to go right 4. So your first dot should literally be on the 4. Like that. Okay. And then you move up 1 to the left 4 to get the other one. So right over there. Okay. What type of line this time? Dotted. Okay. And the only thing you have to be aware of is make sure that whatever point you pick isn't on the line. Okay. My advice, always pick 0, 0 if 0, 0 is not on the line. It's easy. Okay. It's just easy. If 0, 0 is on the line, chances are one of your other 4 points with like 1, 1 won't be, 1, negative 1, negative 1, negative 1, or 1, negative 1. One of those 4 won't be. So if 0, 0 is on the line, and I think you have one of those on your worksheet, just pick another number, pick another point. Okay, it's whatever you want to do, but you got to pick one. All right. Now, when you go to test that point 0, 0, you have choices. You can go back to your original equation here in purple. You can go back to this one right here. Okay. It doesn't matter which one you pick, as long as from here to here you did everything correctly. Okay? Doesn't matter. I'm going to go to the top. All right, so 0 plus 4 times 0. Greater than 2, so the left side becomes 0. So 0 greater than 2, true or false? That's false. So that means this point here is not part of your solution, which means this whole entire side is not part of your solution, which by default means this side is your solution. So instead of shading the bottom side towards 0, 0, we're going to shade the top side away from 0, 0. Add x first, right? So you get negative 2y greater than or equal to x plus 4. Divide by negative 2. Make sure you do it to everything. Which means y is what? What's the next words that come out of my mouth? Y is? Less than or equal to. Why? What'd you divide by? A negative. And you're working with an inequality. So you got to flip it. That still holds true. Always holds true. Okay? So you divide it by a negative. So you got to, I'm going to do it in red. So you got to flip that inequality sign. Alright? Which means negative 1/2 x minus 2 is your line. That's what you graph. Okay. Now you can get this problem fully correct. Excuse me. You can get this problem fully correct with the graphing of the line without flipping that inequality. Where you're going to go wrong is your shading. Okay? Because your shading is what's going to determine whether you that inequality sign rather is going to determine whether you shade up or down, left or right, whatever the line goes. Okay, so you'll still be able to graph the line correctly, or at least, assuming you do that part right. Your shading is what will be backwards. Okay, so you got to be careful with this. Which I got a trick for that too, and I'll show you guys in a second. All right. So we graph. Okay, we go to negative 2 on the y-axis. And we're going to have a negative slope, so we're going to go down 1 and right 2. Going to go up 1, left 2. Remember, 3 points is probably good enough for me just to make sure you get somewhat a straight line. What type of line this time? Solid. Okay, gave you 2 dotted. I figured 1 solid would be all right. You guys are pretty good at drawing solid lines, I would assume, so I figured you need more practice on the dotted. Okay. Now, here's where this problem becomes not tricky. Okay? It becomes not tricky. As long as you do this one thing. When you test a point, you go back to your original. Okay? You test a point, you go back to your original. If you do that, you don't have to worry about whether or not you flip the sign. You don't. Because from here to here, algebraically speaking, you did everything right. Which means this and this one, when you test it, is going to give you the same results. Okay? Or at least where you shade the same way, right? Either they're both going to be true or they're both going to be false, depending on which point you pick. Okay? Now, for example, though, let's say you work this through and you don't flip the sign and you go here, that's when you will shade the wrong way. When you don't flip the sign, you go here. If you go to your original, you'll get it every time. You don't have to worry about flipping the sign at all. You just have to worry about making sure your line is solid. My finger's way below what it should be. Sorry. You just have to make sure you get your line right. Solid, dashed. Okay? So I recommend always going back to the original for your shades. Okay? That saves you guys some stress. So let's do so. So negative 0 minus 2 times 0, it all ends up being 0 on the left, which is greater than or equal to 4. True or false? False. So here was 0, 0. We found it false, which means this side is false, which means this side is true. Your homework tonight is a 1.5 worksheet.